Hello everyone, today is January 15th, 2022. The new problem, find peak element. A peak element is an element that is strictly greater than its neighbors. Given an integer array numbers, find the peak element and return its index. If the array contains multiple peaks, return the index of any of the peaks. Oh dear. Uh, you may imagine that numbers minus 1 equals numbers n equals minus infinity. And you must write an algorithm to run it in the big O log n time. That means basically binary search. Example, okay, let me see example. The numbers 1, 2, 3, 1, the output is index 2, that means 0 indexed. Explanation 3 is a peak element and your function should return index number 2. Numbers 1, 2, 1, 3, 5, 6, 4, that's 6, and index 5. I am thinking about return index of any of the peaks. So that means only one of them. I don't need to return all of them. So okay, that's not hard. Numbers that's 1 to 100, and the numbers is basically integer, signed integer, and integer, and the numbers I not equals numbers I plus 1 for all validate I. Okay, that's the function definitions. Let me think. So that's basically okay. Okay, I think that's ascending one. So, okay, no. A peak element. I am thinking for the binary search how I could search all of how. So for the peak, I need search every element of the array, and that requires log n1. That doesn't mean I could search any one of them. Okay, how that happen? Hmm. Oh. Oh. No. No. So I'm thinking a different way to the binary search. That's recursion one. Every time I will get recursion. I divided the array by half, and by half, and I just search the every sub array, array's peak, and return its index. Even in that case, that's still the big O n time. Interesting. Okay. Basically, I got the algorithm, but I don't think that's the big O log n time capacity. That will be the big O n time capacity. Let me finish this one first, then we could discuss furthermore. Okay, again back to the console I used to use, and find peak element dot c. Okay. Okay, so I'm going to define another function, find peak, find a peak, find a peak. Let me think it. Find the peak recursion. Okay, same things. Let's input numbers, anti-start, and anti-end, and I also need the index for the return. Okay. Yeah. I'm thinking, so if I return the peak as the function return, and return the index, the peak index in the parameter, that means every time I have to declare the index here, and declare parameters for the index and call the function, and also need repair that. No, we don't need store the return for the peak. Okay. Okay, so that's missing one for the index end. Okay, so let's declare some mate. We use that later on. I'm thinking, let me think. If I calculate mate, do I need to check its peak? No, we don't need to check the peak if the mate if peak or not. We just divided made to the one of half, or top half or bottom half, to get the search. That will be it. Okay. Simply will equal start plus and minus start divided by 2. Okay. If and start if and minus start one, two, three. 1, 2, 3. I'm thinking 1, 2, 3 is less than 3. no, less than 3. Less than 3, that means equals 2, that will be equal 2 will be fine. So for we need a loop here. For I equals the start and I less than and I plus plus. We also need a return here. We don't need a for. For it's not efficient. So if start numbers we still need to start for. I'm not sure that when the and minus start will be exactly 2, that means 3 inside, but I would think maybe I could do start and return. Yes. Okay, return equals nums start. Okay, for I equals start plus 1, I less equals and I plus plus, then return equals return greater than numbers I. If return minus, then that's the equals return else, that will be the numbers I. Okay, in that case, no, we also need a tell. Not good. So in that here, the index equals start. Okay, so if return my greater than numbers I, no, less numbers I, we need 2 steps. Okay, the return equals numbers I and the index equals I. Okay, that's the one. Then return variable. Else made, we calculate the made, and if we need also 2 indexed half top and indexed bottom. Let me check. So 0, 0, that means we just need -1 to for the initialization. -1. Okay, so find peak recursion numbers start made and the index if that's greater than that one, that means made plus 1 and index bottom. Okay, so every branch we need 2 steps. First one, no, we don't want to call that again, so return top and return bottom. Return equals find one, that's the one. Return bottom equals okay. If return top less than return bottom, that means return equals return bottom. We need a big one and index equals index bottom. Else return equals return top and index character equals index top. Okay, return. Okay, back to the starts and 0 minus 2. Okay, so that's 0 index, so that means start could be 0. Okay, return. Okay, return. We don't need return. We just need the indexed. Okay, return is fine. Okay, return index is much clearer. Okay, and we just call find the peak numbers 0 and the number minus 1 and send out the index of return index as the pointer, and here just return index. Okay, I think the implementation is done. Let me check the logic again. So basically that's recursion, and every recursion for the return termination condition will be the array is less than 3, and we just return the big one, the biggest one. And if that's greater than 3, we just divide the array to 2, top and bottom, and we check tab bottom found made and return the index and the peak as a function return. Then we compare the peak, the top peak and the bottom peak. If the top bottom peak is greater, we just return the bottom return. Okay, and the record index. If the top return is bigger, we just do the converse. And the major function is simple, just call this function, return the index, that's all. Okay, I think implementation is ready, so I just try to run the code on the Leetcode and see the problem. Here the one, I just delete the one here and paste. Okay, I'm ready to run code. Line 2. Okay, so let me think. The end is fine. Fall and head. Oh, that's wrong one. Okay, run again. Return 38. That's a typo. Fix it and run again. Okay, I got the correct result. Let me submit. Oh, that surprised me. I run it without any problem, so it only beats 89%. Let me read again. $84. I think that's pretty much the result. Let me try the third time. Oh, that's 7%. Oh, that's varying so much. I don't know which value is right. So far I do the binary search. It's not binary search, it's recursion, and do the half-half. Half-half, that means we need to search both top and bottom, and how that is big log n. That's my question. I don't have answer right now, but anyway, I think this one is done. So I got accepted result, and so far I don't think that's big O log n time capacity. I will keep working on that one to make sure I got right answer. So far, that's for today. Thank you for the watching.